Raghav, and the topic I've chosen for this science fair is Archimedes' principle. Why I chose this project is because when I was swimming in my pool and got out, I felt a lot heavier. And then when I went back in, I felt a lot lighter. And I wanted to know why. And I realized this was all explained in Archimedes' principle, which states when a body is immersed fully or partially in a fluid, it experiences an upward force which is equal to the weight of the water displaced by it. And now I'm going to demonstrate Archimedes' principle. So I have a spring balance and a sandbag, and if I weigh this sandbag, it shows 2 Newton, which is equal to 200 grams. And now I'm going to weigh it inside water. And it shows 0.8 Newton, which is 80 grams. And now, to get a buoyant force, we need to subtract the apparent weight, which is the weight inside water, from the real weight, which is the weight outside water. And if we do this, and our real weight is 200 grams, and our apparent weight is 80 grams. And if we subtract the two, we will get 120, which is our buoyant force. And now, we are going to calculate the weight of the displaced water. So, and now it shows 32 Newton. And now with the water it shows 140. And if we subtract the two, we will get 108, which is the weight of the displaced water. It is showing 108 because, and 108 is closer to 120. It is actually showing 108 because the spring scale is actually not an accurate value. It only shows the apparent value. And now, why did Archimedes come up with this principle? There's actually an interesting story behind it. Well, once upon a time, there was a fellow named Archimedes who was born on 289 BCE in Syracuse, Sicily. One time, the king of Syracuse asked his goldsmith to make a crown for him, and when it was done, he suspected that the goldsmith has cheated him and used a little bit of gold. But the king could not prove this, so he called in his most intelligent scientist, Archimedes, to help with this problem. At first, Archimedes did not know how to solve this. So, thinking about this, he went to take a bath in a fully filled tub. And when he climbed into the tub, he realized that some of the water was overflowing. And he also realized that the more he went into the water, the more water was overflowing. After realizing this, he jumped out from the tub and ran out in the streets shouting, "Eureka! Eureka!" which in Greek means, "I have found it." And what did he find? He found the answer to the king's problem. Well, all Archimedes needed to do is, if he got the crown and got a lump of pure gold and put them in 2 different jars and see how much water it displaced, Archimedes could tell if the goldsmith has cheated or not. If they displaced the same amount, then the goldsmith was actually true. But if they displaced different amount, then the goldsmith has actually cheated the king. But what if the goldsmith has only used 10% silver? Then it'll be too hard to notice the difference between the two, right? So Archimedes came up with a brilliant idea. So I actually would show you the experiment, but I actually don't have a lump of pure gold and a fake crown. So, but I have two objects that weigh the exact same. One sandbag and a rice bag. And now I put these both on the weight balance. So now they weigh the exact same. And when I put them in water, the sandbag, since it has more density, it is sinking, while the rice bag is floating. Similarly, the gold crown was afloat, while the lump of pure gold was actually sinking, which actually proved that the goldsmith was cheating. And that's how Archimedes' principle was created. Now, when we talk about Archimedes' principle, it's all about buoyancy. When you talk about buoyancy, the first thing that comes to mind are ships. And how do ships float? Well, ships are actually designed in such a way to displace a lot of water that is greater than its weight. And also, the bottom part of the ship is actually usually hollow, which decreases the density.